Okay, a point of inflection. Remember, the definition of a point of inflection from previously is the point at which the concavity changes. So this one going from being concave downwards to being concave upwards, and the concavity changes at that point. Now, a necessary condition for this is that the second derivative is equals to 0, but it's not a sufficient condition. Okay, so you need to have something else to make sure it is a point of inflection. So all point of inflections will have the second derivative equal to 0, but not all points with the second derivative equal to 0 are point of inflection. So to check that it is a point of inflection, you also need to check that the concavity changes. So it goes from being concave down to concave up, which means that the first derivative of x is the same on both sides. Okay, because here the first derivative of x is positive and the first derivative of x is still positive. And if it's one going the other way, the first derivative of x is is negative. So the first derivative is negative, it's a downward slope. As it goes through that point, if it carries on up here where the first derivative now becomes positive, it's not going to be a point of inflection. It needs to carry on downwards, so the concavity changes, but the first derivative remains negative. So this is one where the first derivative is positive at all times, and here the first derivative is negative at all times. And as it goes through this point, the first derivative is just touches 0, it just flattens out. So you get a 0 first derivative. But on both sides, the first derivative remains the same.